part 2 of the introduction to maximum and minimum values. And we're picking up here with the idea that we're going to find the absolute max and min for a continuous function on a closed interval. And because of the extreme value theorem, I know that there's going to be an absolute max and an absolute min somewhere on this function in this closed interval because it is continuous. So the steps here, we need to find the critical numbers of f of x in the interval a to b, and then find the values of f of c at those critical numbers. So basically we're looking in the interior of that interval, not including the endpoints. And then for the step 2, you'll find the values of f of x at the endpoints. So at the a and the b in that interval a to b. And then we're going to just take the largest value from steps 1 and 2. It'll be the absolute max. The smallest value from steps 1 and 2 will be the absolute min. So basically we're going to find candidates in step 1 and then find the y values at those candidates. And then we'll find the y values at the endpoints, and we'll compare them all and find the absolute max and min. The biggest will be the max, smallest will be the min. So let's go ahead and take a look at this example here. You got x cubed minus 6x squared plus 9x plus 2 on the closed interval -1 to 4. So for the first step, I will find the critical numbers. And the critical numbers basically are just going to be places where the derivative, the first derivative, is equal to 0 or where the first derivative does not exist. So I'm going to first find f prime of x, and this will be 3x squared minus 12x plus 9. And the first thing I'd like to do is just check and see if there's any places where the derivative won't exist. And in this case, it's a polynomial, and the domain is all real numbers. So the f prime of the x is going to exist on all the real numbers. So there's no reason to keep moving forward with that. So we'll just go ahead and focus on the f prime of x equaling 0. Where does that happen? Those are going to be my candidates for the absolute max and min. So we'll set that 3x squared minus 12x plus 9 equal to 0, and then start breaking this down. I noticed the 3, the 12, the 9, all divisible by 3, so I'm just going to factor that out and get it out of there. So I'll have x squared minus 4x plus 3 will equal 0, just dividing the whole equation by 3. And then this does factor, so we get x minus 3, x minus 1. So our two factors, those will be equal to 0 when you multiply them together. So that means that x equals 3 or x equals 1 are going to be our critical numbers. And we'll go ahead and find the y values at those critical numbers. So you plug in 1 into the original function. So we got to go back up here to the original function, and we'll have 1 cubed minus 6 times 1 squared plus 9 times 1 plus 2. You work that all out, you get a value of 6. Do the same thing with 3. So you get 3 cubed minus 6 times 3 squared plus 9 times 3, and then plus 2. We work that all out, you get 2. So right here we've got 2 candidates for our absolute max, absolute min. Let's go ahead and check the endpoints. So for the endpoints, we just simply plug in the endpoints of the interval, in this case the -1 and the 4. So I'll find the f of -1. This is -1 quantity cubed minus 6 times -1 quantity squared plus 9 times -1 plus 2. Simplify all that, you get -14. And then f of 4, the other endpoint, we would get 4 cubed minus 6 times 4 squared plus 9 times 4. And then plus 2, you work all that out, you get 6. And then in step 3, you just make a comparison of all these y values that you got from your critical points, from the endpoints, and you find that the absolute, if I can spell absolute, so your absolute max in this case looks like the highest point that we got was 6 for the y values, and there were actually 2 places, so it's an absolute max was 6 at x equals 1 and 4. Sometimes they'll ask for this, sometimes they won't, but I always like to point it out. The max is a y value and it occurs at a couple of different locations in the domain. And then the absolute min in this case is at negative 14. It only occurred at one spot. The negative 1. All right, and that's all there is basically to that section. You just get your critical points using the derivative and then use the endpoints on your closed interval, and you plug all those in and compare your y values. Thank you for watching.